Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. In today's webisode, we're going to build on what we talked about yesterday with adding decimals and kind of flip it and use the inverse of subtracting decimals. So, let's not waste any more time. Let's take a look at this bad boy up here. Subtracting decimals. It says, Mr. Lehner sprints 200 meters in 21.16 seconds. If you ran the first half of the race in 11.25 seconds, how long did it take him to run the second half of the race? So similar question as yesterday. We're going to talk about subtracting decimals now to figure out different parts of this race here. Again, 200 meters is halfway around one lap around the track. So again, I've broken it down into the first 100 meters and then the second 100 meters. If you've ever watched the Olympic sprinters, you'll see it's almost like a stopwatch. They kind of break down, they call them splits. If they're running a 400 meter race, every 100 meters they do a split on how fast that person runs around the track. Or in this case, a 200 meter race, which is halfway around the track, they're going to do a 100 meter split to see how fast the first half of the race was compared to the second half of the race. So, what information do I know? I know that I'm running 200 meters in a total time of 21.16 seconds. I know that I ran the first half in 11.25 or 11 and 2500th seconds. How long did it take me to run the second half of the race? And hopefully I did well as I break through the barrier here. Yeah, with our little picture there. So, I know that I can use subtraction in this problem to help me figure it out. I'm going to take the total time of 21.16 and I'm going to subtract the first half of the race. So I'm going to subtract 11.25, which is the first half 100 meters that I ran. That gives me 9.91 seconds. So I have to figure out, well, what does 9.91 mean? Yes, I type it in my calculator, I get this nice little fancy decimal, but I don't know what it means. So this is where we kind of use our little rational and reasonableness in our answer. It would take Mr. Lehner 9.91 seconds to run the second half of the race because, and here's my justification, this is how I know that I'm correct. If I add 9.91 plus 11.25, that's going to equal 21.16 seconds. So again, here's what I ran the first half of the race, the first 100 meters, I'm sprinting all the way down, I'm running, maybe get a little sweat going on my head there. They clocked me at 11.25. Well, now I have that second 100 meters to run. So I start sprinting a little bit faster in the second half, and I ran it in 9.91 seconds. So I guess I turned on those speed bursts down the stretch there. But again, I use subtraction here. We're going to talk about fact families coming up. That's a little preview for tomorrow's webisode. But I use the subtraction here, and I use the inverse to double check my problem. I added these two numbers to get the sum, which we know is going to be the biggest number. In the subtraction problem, we know that that's going to come first, and I subtracted my first half of the race to give me my second half of the race. So there's a perfect opportunity to use subtraction with decimals in a real life situation. And those of you that are future cross-country runners or track stars or speed skaters, any type of sports that you have that uses decimals or specific seconds in there, this would be a great opportunity for you guys to use decimals. Alright, your turn. In this problem, you are going to try and figure out what do you need to use to solve the problem. It says the Prairie Junior High basketball team averages 52.6 points per game. If Arton and Niles average 21.8 points together, what does the rest of the team average each game? So again, they have a couple of averages up here of decimal points per game, how much these people are averaging, and you're trying to find how much the rest of the team averages. I know you're ready to go, so go ahead and pause that video. We'll see what you come up with. Okay. I know that the team total average is 52.6 points per game. That's what the whole team together is going to average. I know that Arton and Niles are averaging 21.8 points together. So two of these players average a big chunk of the points here. You might say that they score a lot of points for our team. It says, what does the rest of the team average each game? So now I'm trying to find out what the other members of the team average per game. I can use subtraction in this problem. So I'm going to take the total points that our team averages, which is 52.6. I'm going to subtract the points that Arton and Niles have. So they average this much points per game, 21.8. When I subtract those two numbers, it leaves me with 30.8 points. Well, again, what does that information tell me? Yes, it's a decimal, but I got to figure out, well, what does that decimal mean? 30.8 tells me what the rest of the team is going to average. The rest of the team averages 30.8 points per game because, again, here's that justification. This is why I know that I'm correct. This is why I know my answer makes sense. If I add 21.8 points per game, which is our 10 of Niles, plus 30.8 points per game, which is the rest of the team, it's going to average the 52.6 points per game that the entire team together averages. So again, make sure you double check the reasonableness of your problems. Again, I use subtraction in these problems to figure out the certain areas of what the other team can average. If I wanted to get into percents, which eventually will be coming up for you guys, I could figure out what percentage of the points do these two guys score of the team. You can break it down into individuals. So those of you that are in sports teams, or even if you want to do it on a test in percents to kind of work with that, that's something else that you might want to do to kind of challenge yourself. And then today, brought us a nice little handy dandy little prop. Let's see if we can score this one in there. We'll say it was close enough. 2 points for Prairie. Thank you for tuning in to Mr. Lander's Math Extravaganza. As always, we'll see you next time.